We have learned the addition rule for probability, and that is that the probability of A or B is going to be the probability of A plus the probability of B minus the intersection. Now, this version of the addition rule is used when we have non-mutually exclusive events. And that's a fancy way of saying we have events that could be in more than one category. We also learned a formula for the mutually exclusive events, and that is going to be the probability of A or B will equal the probability of A plus the probability of B, and that's it. Because the intersection for mutually exclusive events is 0. So now let's do a few practice problems using both of these rules. Problem 1 says to find the probability of rolling a 6 or a 2 on one roll of a single die. Now, when I think about this, I think, can you be both of those? So can I be a 6 and also a 2? The answer is no. So I'm going to use probability of A or B is just going to be probability of A plus probability of B. The key word here is or. When we see or, we think addition rule. So this is going to be the probability of rolling a 6 plus the probability of rolling a 2. The probability of rolling a 6 is going to be 1 out of 6 plus the probability of rolling a 2. Well, there's just 1 2 here, so 1 out of 6. And then when I add those together, I get 2 6, or simplified to be 1/3. Now let's look at the next one. The next one says, find the probability of rolling a 6 or an even number. Now for that, I do see some overlap. That means we're going to use the addition rule for non-mutually exclusive events. So the probability of rolling a 6, and then there's that word again, or. So or means union, an even number on one roll. This is going to be the probability of rolling a 6 plus the probability of rolling an even minus the probability of 6 and even. All right, so this will equal probability of rolling a 6, well, there's just 1 6, plus the probability of rolling an even, well, there's 1 2 3 out of 6 even numbers. Then I need to subtract the probability of being 6 and even. Well, if I look at this right here, 6, that is 6 and that is even. And there's only one out of the 6 outcomes that is 6 and even. So I'll subtract 1/6. This will equal 3/6, which equals 1/2. All right, the next problem is talking about picking a face card or a diamond when drawing one card from a standard deck of cards. And I've included a pictorial representation of a deck of cards. You don't have to memorize that. But let's see what this problem is asking for. The probability of picking a face card or a diamond. Now, if I look at these face cards here, are any of them diamonds? And the answer is yes. So there is going to be some overlap. So I'm going to find the probability of a face card, or, there's that word again, or a diamond. This will be a probability of a face card plus the probability of a diamond minus the probability of a face card and a diamond. Okay, so let's look at this Venn diagram right here. We have all the diamonds listed. And in the bottom circle, we have all the face cards listed. But something interesting is happening right here. And that is that the Jack, Queen, and King of the diamonds have been put in the intersection because those are both face cards and they are diamonds. So that means 3 out of our 52 cards. So let's put this all together. So we're going to have the probability of being a face card. If I look here, that's going to be these 12 cards, or you can count up the 12 that are in this Venn diagram. So 12 out of 52 plus the probability of being a diamond. We can come over here and count all the diamonds, or we can count all the diamonds in this circle, either one. So there's 13 diamonds. Then we need to subtract off the cards that are face cards and diamonds. If you're looking at just the deck of cards, that's going to be these 3 right here. They got highlighted blue and they also got highlighted yellow. So that's where the overlap is. Or you can look here on the Venn diagram and see where they overlap. So this will be minus 350 seconds. This will equal 2250 seconds, and we could simplify that to be 1126. Now, if you're really curious, you can go back to this Venn diagram, count up everything that is contained within these 2 circles, including the intersection. You will find that this number is equal to 22, which is where we get the 2250 seconds for our probability. All right, let's look at this next one. The probability of picking a face card or 2 from a standard deck of cards. All right, let's first look at the set of cards down here. So here are our face cards again, and then let's highlight the 2s. We could see that these 2 events are mutually exclusive. There is no overlap. We also see it here in our Venn diagram. We have all the 2s listed in this top circle. Then we have all the face cards listed in this bottom circle. And as you can see, this middle part, this intersection, is completely empty because there aren't any 2s that are a face card, and all the face cards are Jack, Queen, and Kings. They're not 2s. So for this one, we can use our mutually exclusive event formula. The probability of being a face card or a 2 is going to be the probability of a face card plus the probability of a 2. Now, for just a moment, let's say we start doing this problem and we don't realize that there isn't an intersection. We're just going to start off the problem and be like, okay, now I'm going to subtract the probability of a face card and a 2. As I get into this problem, I'll realize, hey, the intersection here is 0. So this will go away. So sometimes I like to just always start off with the addition rule for non-mutually exclusive events, knowing that sometimes the intersection will be 0. If you want to memorize them differently and figure out if it's mutually exclusive or non-mutually exclusive, that's totally fine. Everyone has their own way of looking at these problems. So let's finish this up. The probability of being a face card, there's 12 out of 52 cards, plus a 2, that's 4 out of 52 cards. So I add those together, I get 1650 seconds, and that will simplify to 4/13. Okay, now you could try some problems on the addition law.